Greetings everyone from Dakar, Senegal. My name is Djim M.L from Cheikh Diop University of Dakar. It is a great honor for me to receive the 2024 Falkenmark Award, and I'm deeply grateful to share my research with you today, albeit virtually from Dakar. This recognition holds special significance as it acknowledges our contribution to understanding water dynamics in water-limited environment, a challenge that Professor Malin Falkenmark has championed throughout her remarkable career. So this is the outline of our presentation. As an introduction, we face critical challenges in water-limited environment. And as you can see here in this map, drylands cover 40% of Earth's surface, affecting the lives of 3 billion people. Specifically in sub-Saharan Africa's country, where our research was conducted, 95% of agriculture depends entirely on rainfall. And this creates significant vulnerability to water scarcity and climate variability. Furthermore, these challenges are exacerbated by climate change, leading to increased socio-ecological vulnerability and decreased agriculture productivity. In addressing these challenges, our research focused on two strategic solutions. First, groundwater, which serves as a resilient resource in sub-Saharan Africa's country. And second, agroforestry systems, particularly Fédérbia albida parklands in Senegal, which provides crucial ecosystem services to local communities. However, quantifying water flux in these systems present significant scientific challenges, notably in data scarcity and the need for parsimonious approach to understand evapotranspiration, partitioning, groundwater recharge estimation, and ultimately the impact of these systems on the water cycles component. Therefore, our research aimed to contribute to the understanding of hydrological processes at the soil vegetation atmosphere continuum in Senegal. And we established three primary objectives with three publications. First, to evaluate different approach for soil vegetation atmosphere model parameterization. Second, to assess the hydrological impact of Fédérbia albida backlands on the water cycles. And third, to estimate water flux using the isotopic approach. Given our time constraint today, I will focus on our findings from the water stable isotopic investigations. So our research was conducted at two contrasting sites in Senegal. The first site in the Groundnut Basin represents an agroforest system, as I already mentioned, with Fédérbia albida parkland and crop rotation of groundnut and millet. While the second site was located in the Ferlo Valley and offered different environmental conditions for studying the hydrological processes. And this experimental design allows us to investigate water dynamic across different climate regions as seen in this map. Our methodological approach includes comprehensive sampling campaign from 19 to 21, including systematic collection of daily rainfall, soil water profile, and groundwater samples. For soil profile, we sample soil at different slope positions, as you can see in these figures. And at site 1, we sample under and outside Fédérbia albida. And the analytical work conducted at Université in Vienna includes gravimetric water content measurement, granulometry, soil bulk density, and water stable isotope of all samples. So we employed isotopic approach for partitioning the evapotranspiration following an isotopic mass balance method based on Lebach and R works. And we use the deuterium shift model from Allison and R work for recharge estimations. So our findings reveal several key insights. First, in terms of the isotopic signature, we can see here distinct characteristic at both sides, with local meteoric waterline close to the global meteoric waterline, but with lower slopes, reflecting the influence of local climate conditions at both sides, particularly low relative humidity at site 2. Soil water was more enriched due to fractionation process of evaporation, and the groundwater at site 1 was relatively close to local meteoric waterline. So the soil profile show a key discovery with an identification of 2 distinct soil water zones, an upper horizon extending 1.5 meter at site 1 and 1 meter at site 2 demonstrate dynamic response to rainfall and evaporation. And below these depths, we observe a stable zone characterized by a constant isotopic composition, suggesting different water movement mechanism at these both zones. Perhaps most significantly, our groundwater recharge estimate indicate an average diffuse recharge of less than 6 millimeter per year, representing less than 2% of annual precipitation, and this finding align with previous studies in similar semi-arid environment. However, we also discover evidence of preferential pathways, particularly near Federia albida trees, as shown with the modeling results, and suggesting a more complex recharge mechanism than previously understood. Regarding the water flux partitioning, specifically the evapotranspiration partitioning, our analysis reveals a clear seasonal patterns, and we take example from site 2 results. During the dry season from February to June, soil evaporation rate ranged from 0.02 to 0.16 millimeter per day, with high rates observed at low slope position due to higher soil water content and clay content. And as vegetation develops during the growing season, transpiration becomes dominant, with groundnut crops showing rates of 0.5 to 1.2 millimeter per day, and pasture vegetation at site 2 here ranging from 0.5 to 0.9 millimeter per day. So in conclusion, the implication of these findings are substantial for water resource management in this region, and our work provides 3 key contributions to the field. First, a comprehensive isotopic characterization of water movement patterns in the soil and in the weather zone, to be more specific. A reliable quantification of water flux and partitioning using parsimonious approach, and a critical insight into groundwater recharge process. And this finding advance our scientific understanding, but also provide practical insight for water management in similar climate conclusion. I would like to extend my sincere gratitude to the award committee and to all colleagues who support this research. Thank you for your attention.